Greetings from Mission Control Houston and welcome to Space Station Live. Joining us here inside of the International Space Station Flight Control Team, looking down at the Orbit 2 team as they're manning consoles, monitoring all of the systems on board this orbiting laboratory. Inside the control room right now, Flight Director Bob Dempsey seeing over the team. Joining him at the Capcom position, Steve Bowen, serving as a communication link between the Flight Director and the astronauts up in space. And those astronauts right now are the crew of Expedition 36. They're being led by Russian cosmonaut Pavel Vinogradov, a veteran Russian space flyer on his third flight into space. Joining him are another Russian cosmonaut Alexander Mazurkin, currently on his first flight, and NASA astronaut Chris Cassidy on his second flight, having previously flown on a shuttle mission STS-127. On the right side of this picture, you have our three newest residents on board the International Space Station. Russian cosmonaut Fyodor Yurchikhin of the Russian Space Agency. Behind him, the tall gentleman Luca Parmitano from the European Space Agency on his first flight. All the way on the right there, NASA astronaut Karen Nyberg, rounding out this sixth crew contingent. It's a fairly busy week for the astronauts on board the International Space Station. Quite a bit of research and maintenance work being conducted as they move throughout the week. Pavel Vinogradov, current commander of Expedition 36, has quite a few tasks on his schedule. He'll be studying the cardiac bioelectric activity of his own body while at rest. This one of the many biological experiments that these astronauts do as expedition crew members on board the International Space Station, serving as guinea pigs themselves for many of these experiments. Throughout the week, Vinogradov has also been involved in a lot of maintenance activities throughout the Russian segment, cleaning out many of the ventilation systems and taking photographs. We'll also be replacing quite a few of the fan screens inside of this ventilation system, and also doing some inspection and photography of the windows inside of the Zvezda service module. He'll be sending these photos down to the ground to Russian controllers in Koryov, just outside of Moscow, as they continue to take a look at the windows, just always checking for any possible imperfections or damage from potential micrometeoroids. He'll also be doing some more work inside of the Russian segment, replacing some directional airflow sensors. Second Russian cosmonaut Alexander Mazurkin doing a few biological studies himself, starting off mornings with the Sprut-2 experiment, which looks to observe the liquid components of a crew member's body, such as the cellular liquids and blood flow, while in this microgravity environment of space. His task list is also loaded throughout the week with a lot of experiment work, beginning to set up the Molniya Gamma experiment, which will look at gamma radiation splashes and optical radiation during terrestrial lightning and thunderstorm conditions, using three sensors. This is an external payload attached to the outboard section of the Russian segment on board the International Space Station. He'll also be taking a few measurements from the Russian Matryoshka experiment. This is a upper torso mannequin-sized doll on board the station with a number of dosimeters placed throughout it that serves as a radiation monitoring device, giving information to teams down on the ground just how much radiation these astronauts are being exposed to during their expedition space flights. He'll also be throughout the week taking some observations for the Russian Signer investigation, which looks at the world's ocean areas on a specific latitude belt, searching for bioproductive water areas for both commercial fishing and biological research studies. He'll also be doing a few maintenance tasks himself on the Russian systems, specifically focusing on the Russian Electron system, which is one of the oxygen generating devices on board the International Space Station. You can see a picture taken with the previous expedition crew here holding up some of those Electron generators. Meanwhile, NASA astronaut Chris Cassidy pretty much focusing his entire week on preparation for some upcoming spacewalks that he'll be undertaking. He'll be stepping outside into the vacuum of space on 2 spacewalks over 2 weeks. Joining him will be ESA astronaut Luca Parmitano, Cassidy designated EV-1, Parmitano EV-2. This will be Cassidy's 5th and 6th spacewalks of his career. He already has 23.5 hours of spacewalking time in 4 previous EVAs, including the unplanned ammonia leak repair that took back on May 11th. Cassidy will be preparing his EMU or extravehicular mobility unit, the spacesuit that he'll be wearing throughout this spacewalking procedure, checking out the glove heaters and also the battery systems, and doing an on-orbit fit check verification. He'll be joining that fit check verification by Parmitano and fellow NASA astronaut Karen Nyberg. He'll also be going over the procedures in a conference with spacewalk officers down here on the ground in Mission Control Houston. Also doing a software review of what's known as the DUG, the Dynamic Onboard Ubiquitous Graphics System. Aside from all of this EVA preparation throughout the week and over the weekend, Chris Cassidy will also be doing quite a few experimental works. He'll be working with the binary colloidal alloy tests, preparing a few samples for installation in this experiment, also known as BCAT for short. This experiment looks to document the formation of crystals from microscopic spheres known as colloids while they're suspended in a liquid in microgravity. He'll also be conducting his own monthly periodic fitness evaluation, which will be performed on the CVIS, one of the exercise devices on board the International Space Station, CVIS standing for Cycle Ergometer with Vibration Isolation and Stabilization. That vibration isolation is a standard feature on all of the equipment devices on board the International Space Station, as they protect the rest of the delicate station systems from the vibration generated by these crew members while they're conducting their exercise on board. Each of these astronauts working out for about 2.5 hours every single day while in space in order to combat all of the negative effects of weightlessness on the human body. Also, Chris Cassidy will be getting in some more time throughout the week on the SPHERES experiment. SPHERES standing for the Synchronized Positioned Hold, Engage, Reorient Experimental Satellites. They're these small, self-contained, bowling ball-sized objects which are used for a number of different exciting experiments, including formation flying and the development of algorithms by students and teams from schools across the country. They get a chance to follow along with the expedition astronauts, watching as these satellites conduct various flying maneuvers such as rendezvous and docking, and also, again, that formation flying. So Cassidy doing a few SPHERES test runs throughout the week. Moving on, our third Russian cosmonaut, Fyodor Yurchikhin, one of the newer members on board the International Space Station. Quite a bit of maintenance work on his task list over the week inside of the Russian segment. He'll be installing 2 adjustable length hoses inside of the Russian gas-liquid mixture filter. Also taking some time to conduct the Russian bar experiment, which looks to develop various methods for detecting depressurization in any of the modules on the Russian segment. He'll be working that in tandem with controllers down on the ground, which will be simulating a number of different test runs for him. We'll also have some standard software loading activities on some of the Russian laptops, just doing a few updates to some of their controlling systems. Also getting his hands on some of the experiment work on the Russian segment. He'll be working with the Russian identification experiment. That's an ongoing investigation looking into the various dynamic loads that the International Space Station's Russian segment structure is subjected to during different dynamic operations. Some of these dynamic operations include docking of visiting vehicles, also station reboosts, the physical exercise of the astronauts themselves, and also any extravehicular activity or spacewalks. The Russians having just completed one back in late June, and the U.S. OS crew members getting ready to complete 2 over the next 2 weeks. European astronaut Luca Parmitano joining Cassidy and much of his activities this week as they continue to prepare for those 2 upcoming spacewalks. He'll be doing an on-orbit fit check verification of his own spacesuit along with Cassidy. He'll also be responsible for doing a checkout of their SAFER devices. SAFER stands for the Simplified Aid for EVA Rescue. The SAFER are small nitrogen gas-powered backpacks that the astronauts wear, sort of acting as their life jacket during these spacewalks, aside from the regular contingent of tethers and hand grips that they use to keep attached to the station. The safer can serve as a last resort should the astronauts begin to float away free from the station, getting them back to safety. Parmitano also scheduled to do his own monthly periodic fitness evaluation, also on that CVIS device, and then doing some pretty major maintenance tasks on board the station for their various ECLS, or the environmental regeneration systems. He'll be inside of the European Columbus module, working on removing and replacing the Columbus's water processing assembly number 2, and also replacing some items inside of the waste and hygiene compartment. He'll be replacing some of the piping between the pump separator and the pre-treat and water pump. You can see the waste and hygiene compartment, a fancy word for the astronauts' toilet facilities on board the International Space Station, requiring some pretty regular maintenance, as it is a fairly vital piece of equipment on board the station. These astronauts, not only spacewalkers and scientists, also working as space plumbers in their time on board. And then our final Expedition 36 crew member, Karen Nyberg, doing some robotics workstation checkouts over the rest of the week. She'll be responsible for conducting all the robotic operations during Cassidy and Luca Parmitano's spacewalks, controlling the station's Canadarm2, or the robotic arm. She'll be doing a checkout of that display and control panel, also continuing with a lot of giving a hand with all of the spacesuit or the EMU preparations, and going over all of the spacewalk procedures. She'll be doing her own review of the space station's robotic arm, or the remote manipulator systems, DUG. The DUG, again, standing for Dynamic Onboard Ubiquitous Graphics. She'll be doing that review with spacewalk officers down here on the ground. Aside from that, quite a bit of experiment work for her. Aside from doing some EarthCam setup. The EarthCam is the Earth knowledge acquired by middle school students. She'll be setting that up towards the end of the week, and preparing that for middle school students to control and take photos of various locations around the world. She'll also be working inside of the combustion integrated rack, removing and replacing one of the multi-user droplet combustion apparatus fuel reservoirs. These reservoirs are used to contain the liquid fuel used during droplet combustion experiments. That combustion integrated rack is a self-contained rack on board the International Space Station for various combustion experiments, providing a safe environment for all of the igniting. Aside from that, Nyberg will also be able to take some time to answer questions from reporters in Minneapolis, Minnesota, inviting them on board the International Space Station, that event on NASA TV. So, as mentioned, much of the activity for our U.S. crew members and also our European Space Agency crew member Luca Parmitano this week, preparing for 2 upcoming spacewalks, one on July 9th and one on July 16th. Both spacewalks scheduled to last about 6.5 hours. We'll see Cassidy and Parmitano stepping outside to, among other things, replace a space-to-ground communications receiver, as well as some wireless video equipment, installing a number of power cables and networking cables for an upcoming Russian multi-purpose laboratory module scheduled to be launched a little bit later this year. The first of those spacewalks, again, taking place on July 9th. It's also dubbed EVA-22. We now have a video narrated by lead spacewalk officer for EVA-22, Ernie Bell, giving an overview of all the tasks that Cassidy and Luca Parmitano will be undertaking in order to accomplish everything on their list.
We'll start out EVA 22. Chris is going to be wearing the red stripes. He's going to be egressing first, and he's going to do so with a spare space-to-ground transmitter receiver controller. Luca Parmitano, then, he's going to be wearing the plane suit, will egress second, and he'll take with him a cover for one of the MISSI experiments, the Ormate. So the first task for Chris, he'll translate aft on the airlock and up to the top of Z1, and he's going to get in position to replace the failed SGTRC. So he'll first stow the bag with the replacement SGTRC on top of the Z1 truss. He'll set up a temporary hardware stanchion, which he'll then attach the spare SGTRC to. So he retrieves it and places it on top. He'll then move over to the failed unit and get in position to release it via 3 bolts. Here you actually see a picture of Chris in the neutral buoyancy lab practicing this actual procedure. Once he's removed the failed one, he'll grab the spare and install it into the same location. And once complete, he'll stow the failed inside the bag, place the hardware stanchion inside the bag, and close it up. Once complete with the task, he'll return to the airlock where he'll stow this entire bag inside. Now, while Chris has been working on the SGTRC, Luca has translated up the CETA spur to the outboard side starboard truss to the Express Logistics Carrier number 2, where the MISSI experiment is located. This actually includes 2 items, the optical reflector materials experiment, or the Ormate, and the payload experiment container, the PEC. So he'll get up onto position there on the forward zenith side of ELC2. And first thing he'll do is take some pictures of the material experiment. He'll also look over at inboard and take some photos of the AMS. Put a cover on the Ormate, remove it, and place it on his mini workstation. He'll then close the PEC, where the experiment was actually inside of it now. And here's a photo of the experiment on orbit, so you can see the hardware. He'll demate 2 cables from the PEC and connect them to the base. At this point, he'll release the PEC payload and stow it on his body restraint tether and translate back to the airlock. At the airlock, he'll actually stow both the Ormate and the PEC inside, and we can expect both the crew to be back at the airlock together at about this time. They'll then begin their next task, which is a starboard radiator grapple bar install. For this, Chris will translate up to the starboard CETA cart with a large RU bag that he's going to use for some flight support equipment brackets that he'll later remove from the RGBs. So he'll place this bag on the CETA cart. He's going to actually take out a large or a handling device, go up onto the mobile base system, and place this handling fixture or scoop onto the mass camera. This is for use later by Luca. He'll then go back to the CETA cart. Meanwhile, Luca has been retrieving a foot restraint. He'll actually gather this from the forward side of the external stowage platform number 2. He'll put on his BRT and then translate out port, just slightly port of where Chris has been working, where he'll begin steps to ingress the arm. So once he's on location, he'll put the foot restraint at the end of the arm, and then he'll ingress the foot restraint. At which point, Karen's going to fly him over and get him in position where he'll be able to take control of the first of 2 RGBs. Meanwhile, Chris is moving around, breaking torque on the 4 bolts that hold this first RGB to the second one. On the forward side there, you see him. He'll release 2 bolts, translate around onto the second RGB, and then move back inboard so that Luca can move into position to take control of this first RGB. Once Luca takes control of it, Chris will release the second 2 bolts, Karen will fly Luca out, and Luca will then reposition the RGB into a better attitude for installation over on the starboard thermal radiator rotary joint, or the targe. And this arm maneuver here is going to be about a 15-minute maneuver. So he'll fly up over the station and get into position. Now during this maneuver, Chris is actually going to remove the two flight support equipment brackets that were used to hold the two RGBs together. He'll stow them back in the large ORU bag, which is over there on the seated cart. There's the first one, and now working on the second one. Once he has those both removed, he's going to translate outboard on the starboard side of the truss, and he'll meet up with Luca for the installation of this first RGB. So once in position, the two of them will work together to align the RGB on the stow bolts, on the stow beams. See there, and then they will iteratively work back and forth to secure the two bolts to mount that to the targe. Here's a photo from the neutral buoyancy lab of this task taking place. Once complete, Luke will be flown back towards the second RGB, which is still located at the POA. During the maneuver, Chris is actually going to translate back towards the airlock. And once he gets down to the airlock, he'll translate to the zenith forward high pressure gas tank. And here he'll retrieve the MLM power cable. This was previously staged there by Sonny Williams on EVA 18. The task here is to route the cable along the starboard side of node 1 and onto the PMA-1, or pressurized mating adapter number 1, on the aft side of node 1. Once Chris gets this task complete, he's going to translate back towards the port seated cart where he was earlier to help with the release of the second RGB from the POA. But first, Luca, on the flight over to the second RGB, is going to be brought in to remove a failed mass camera on the MBS. He'll drive a single bolt. That'll release that camera, and then Karen will fly him away and the rest of the way over to the second RGB. And once he's in position, he'll actually hand the camera off to Chris. Chris will then retreat aft near the seated cart. Luca will take control of the RGB. Chris will help work clearances, and they'll fly him out away from the POA. Again, Luca will rotate the RGB for the installation, this time over on the port targe. This flight here is actually about a 27-minute maneuver, so it's a pretty long arm maneuver. So there is, again, some time for Chris to go and work some other tasks. During this flight, then, Chris will return to the airlock, drop off the failed camera, grab two bags, one being a PMA-2 cover bag and the other a crew lock bag. We'll translate out to the forward end of the station, where PMA-2 is, and drop off the PMA-2 cover bag. He's not going to install the cover yet, but he will stage the bag. At this point, he's going to begin translating back to the port targe. Along the way, he'll drop off his crew lock bag. It's for use later with the Z1 Y bypass cable task. We'll translate the rest of the way out to the port targe. And timing working out, Luca will be arriving right around this time. So they'll again work together to stow this RGB in the same fashion that they did the first one. They'll work to align it onto the stow beams, and then take turns iteratively driving the two bolts to secure it to the targe beam. At this point, Luca will be flown back to the same location where he ingressed the arm. It's about a 13-minute maneuver. Be a slightly different orientation, but essentially the same location. He'll egress the foot restraint and then remove the foot restraint from the arm and take it back down to ESP2 where he retrieved it from earlier in the EVA. At this point, Chris has translated back, picked up his crew lock bag, and is heading around to the aft side of Node 1 to a bag there called auxiliary bag number 1, where he's going to retrieve the 2 cables for the Z1 Y bypass task. So retrieve those 2 cables and translate up over the top of Node 1 to the port side of Z1 truss segment. Once he gets onto work site, first thing he's going to need to do is to reorient a foot restraint out of the way, and then he'll stage his crew lock bag. There's just a few tools and caps and such for the cable task. And then he will work the cable installs. He'll actually do a complete install of the Nader cable or the 4 Bravo cable. He'll do a partial install of the 3 Bravo cable or the Zenith one. That one's actually going to be completed on EVA 23. At this point, he returns to the airlock and stows the crew lock bag. At this point is another sync point for the crew where they'll both translate forward on station out to the PMA2 location, where they'll work in conjunction to install the PMA2 cover around the forward end of the PMA2. There's basically a number of Velcro straps that they're going to cinch down onto the handrails around the circumference. One of the crew members then will pick up the PMA2 cover bag, translate back to the airlock. This bag will be stowed inside the airlock and brought inside at ingress. The other crew member is actually going to translate back to the port CETA cart where the large RU bag, which contains those FSE brackets, is going to pick up that bag and then take it down to the airlock. Now this bag actually won't be brought inside on this EVA. The airlock's getting pretty full, so instead the crew is going to stow it on the starboard end there of the airlock. See right there where the handrails are flashing, and now place the bag there. Once it's complete, Luca will ingress first, Chris will ingress second, close the hatch, and this will complete the EVA2 tasks.
That again was lead spacewalk officer for EVA 22, Ernie Bell, giving an overview of Chris Cassidy and Luca Parmitano's plan. That EVA happening on July 9th. Just 1 week later, on July 16th, EVA 23 will occur with the same 2 astronauts stepping outside. And now why don't we take a look at an overview of that given by lead EVA 23 spacewalk officer, Karina Eversley.
So on US EVA 23, EV2 Luca Parmitano will egress the airlock first. He'll be wearing the pure white suit. He'll bring out a bag containing some cables that he'll be installing during the EVA, and then attach his own and Chris's safety tethers outside the airlock. EV1 Chris Cassidy, wearing the red striped suit, will egress and retrieve 2 more large bags from the airlock. One contains the 4 radiator V-guides, and the other is an empty bag in which he'll stow the main bus switching unit multi-layer insulation towards the end of the EVA. Chris will translate up over the airlock and across the top of the Z1 truss, and then down to the port side of Z1, where he will work on the second of the 2 Y bypass jumpers, and this one will have been temporarily stowed on the previous EVA. He'll be working with the upper cables in this view, and what he's actually going to do is swap 2 connectors. In this graphic here, the 2 connectors indicated by the double-headed arrow will swap, and then the 2 connectors in the blue circles will swap. And in the end, then, the green cable will have been replaced by the Y bypass jumper in red, which provides powers from 2 different sources. Meanwhile, Luca will take his bag of cables from the airlock and translate under the Unity node. He'll go to its upper aft end cone, where he'll temporarily stow that bag, and you can see the 2 handrails. He'll stow it between blinking here. Then he'll retrieve the multipurpose laboratory module Ethernet cable from the bag and translate to the forward end cone of Unity, where he'll connect the cable to a spare Ethernet connector that is located in the corner between US Lab and the Unity and Tranquility nodes. Luca will lay the cable out as he translates back aft towards the Russian segment, and he'll be restraining the cable onto handrails and other structure using EVA wire ties. This MLM Ethernet cable actually includes 4 additional extra connectors on its forward end that can be used for future Ethernet expansion capability. When Luca reaches the forward end of the Zarya Russian module, he will tie off the end of the cable on a handrail where a Russian crew will complete the connection to a cable they will route later this year during a Russian EVA. After Chris finishes with the Z1Y bypass jumper, he'll return to the airlock to retrieve the large bag containing the 4 V-guides. And he'll head out over the lab and out to the Port 1 or P1 truss. You can see the translation path he'll be taking highlighted by the handrails blinking there. And then he'll go down to the nadir side, or the bottom side of the truss, where he and Luca installed one of the radiator grapple bars on the previous EVA. Once he's there, he'll bolt the 4 V-guides onto stowage brackets attached to the grapple bar. And like the grapple bars, the V-guides, each one has 2 bolts that zip into the nut first, and then the EVA power tool or pistol grip tool is used to provide the final torque. While Chris is working with the radiator V-guides, Luca will continue with several tasks to finish the outfitting of the power and data grapple fixture, or PDGF, on the Zarya module. And first he's going to be checking for a misconfigured grounding wire inside one of the connector doors, which you see blinking here. Mike Fossum actually cleared one of the connector doors on STS-135. You can see that one in the upper right photo with the little white wire that's poking out of the door there. But the yellow arrows point to a couple little white dots that we can see behind the other door. And we think that although Mike inspected it and it appeared clear, it's possible that the door just pushed that wire out of the way. So in this video, you can see what Luca will have to do is peel back the multi-layer insulation around the PDGF, and he'll use the large hook from his waist tether in order to open the connector doors so he doesn't have to stick his fingers inside there. And he'll do an inspection to see if he sees anything. But then because the door may have actually pushed that wire out of the way, we will locate it. It's a grounding wire for the multi-layer insulation, and just gently pull it out, make sure there's no loose wire inside that connector cavity. And he'll twist it around to keep it out of the way, and then restrain it in place by putting the multi-layer insulation back, and it's just attached with Velcro. And then he'll do one final look inside the connector to make sure everything looks clear. Once he's complete with that task, Luca will release a short segment of the data cable for the PDGF and route it forward onto the pressurized mating adapter. This one's actually attached to the PDGF already, and he'll attach that to a handrail on the PMA. Then he'll return to his cable bag and retrieve the 1553 data cable, which he will attach to that short pigtail. And this actually uses Russian-style connectors on those 2 cables there. And then he'll route the cable across the pressurized mating adapter over to a connector panel on the Tranquility node. And the 1553 cable is actually a pair of cables that have been taped together just to make them easier to route by EVA, and it provides 2 data channels for the PDGF. So after Luca has connected the 2 cables, the ground will do a quick check to verify good communication on both channels. While that's being done, Luca will clean up his work site and retrieve the cable bag. He'll stow that in the airlock and then translate out to meet Chris at the P1 truss for the wireless video system external transceiver assembly, or WETA, antenna relocation task. So this is on the zenith side, just above where Chris was working on the V-guides. And the crew will work together to demate 3 connectors from P1 and then release a single large bolt that holds the antenna stanchion to the space station. They'll position the WETA and its stanchion on Chris's body restraint tether and retrieve their tool bags, and then they will carefully together translate down towards the node 2 Harmony aft end cone. You can see the translation path they'll be taking. And we have them do this together just because the antenna is very large, and so it helps Chris to make sure that it doesn't get bumped into anything along the way. Once at the Harmony's upper aft end, they'll return the antenna to a vertical position and drive the bolt to secure it in the Harmony module. You'll see the Neutral Buoyancy Lab footage of them working with this antenna, and it's about 7 feet long. So it's also one of the 3 antennas that provide our helmet camera video during spacewalks. When this antenna is installed, the crew will then remate the 3 connectors to a connector panel on Harmony, and which provides power to the antenna as well as the video signal back to us. And then they'll retrieve their tool bags and return back to the airlock. Chris will stow the bag that carried the V-guides and retrieve a large empty bag for the main bus switching unit multi-layer insulation. And then he will be heading out to the Express Logistics Carrier number 2 on the zenith side of the starboard 3 truss. You can see his translation path here. And you can also see the alpha magnetic spectrometer AMS right next to that work site. This is the current location of the failed main bus switching unit that was changed out on US EVAs 18 and 19 in August of 2012. And Chris will be removing a large insulation blanket from the MBSU. He'll stow it inside of his bag. And then he'll use some EVA wire ties to restrain the flaps around the perimeter of the MBSU so they don't get in the way of robotic interfaces. And it can be brought inside robotically. During this time, Luca will either be finishing up the PDGF tasks he was working on earlier, or he may assist Chris in completing the blanket removal tasks and taking additional photos of the AMS. And that's the end of the planned timeline. We do have some get-aheads. A key one is the replacement of the camera on the forward corner of the Japanese experiment module exposed facility. Chris Cassidy actually installed this camera on his previous shuttle mission, so he's very familiar with that work site. And then the crew will return to the airlock. They'll stow their hardware, including the radiator grapple bar FSC bag that was left outside from EVA 22 and ingress, and that will be the end of EVA 23.
For the LOS.
And that again, a look at EVA 23, which will be taking place on July 16th.
And your host in Minneapolis is Miss Alex Kendall.
Miss, you said, or I heard Al Kendall.
Miss Alex Kendall.
Miss Alex Kendall, got it.
Capcom Steve Bowen giving a call up to the crew as they're getting ready to speak with some reporters from Minneapolis, Minnesota. You heard the voice of Chris Cassidy calling down. He'll be one of the 2 spacewalkers involved in those upcoming EVAs that we just watched the animations to. Chris Cassidy will be designated EV1. This will be his 5th and 6th spacewalks of his career, having already completed a little over 23.5 hours of EVA time in 4 previous spacewalks. His partner throughout the next 2 weeks will be Luca Parmitano, an Italian from the European Space Agency. These will be his first spacewalks, and he will also be the first Italian astronaut to walk in space, and also the first European space astronaut to conduct a spacewalk since Hans Schlegel during the STS-122 mission back in February of 2008, when they delivered the Columbus module to the International Space Station. Those spacewalks again scheduled to take place on July 9th and July 16th. Both spacewalks will be beginning at 6 a.m. Central Time, 7 a.m. Eastern Time. Our coverage of those spacewalks beginning at 6 a.m. Central Time, 7 a.m. Eastern, with the astronauts scheduled to formally begin the spacewalks at 7:10 a.m. Central. Cassidy, who again will be designated EV1 for both of those spacewalks, will wear a spacesuit bearing some red stripes to make him easily identifiable. Parmitano will be designated EV2, be wearing a spacesuit with no stripes, and again be making the first 2 spacewalks of his career.